Welcome to this presentation on the product array puzzle, where we will discuss an efficient solution implemented in C++. In this session, I will be guiding you through this problem solving approach. Let's start with the problem statement. Given an array ARR, our task is to construct a product array res, where each element in res I is the product of all elements in ARR except ARRI. For example, with the input array containing the elements 10, 3, 5, 6, 2, the output should be 180, 600, 360, 300, 900. This problem has certain constraints, such as the size of the array being between 2 and 1 lakh elements, and each element ranging from minus 100 to plus 100. Here's an example walkthrough. Given the input array 10, 3, 5, 6, 2, let's calculate the result for each index. For I equals to 0, we exclude ARR0 and multiply the rest 3 times, 5 times, 6 times 2, which gives us 180. Similarly, for each index, we exclude that particular element and calculate the product of the remaining elements. The final result will be 180, 600, 360, 300 and 900. The naive approach to solve this problem would involve iterating through the array for each element and calculating the product of the remaining elements. This gives us a time complexity of big O of n square, which is inefficient for large arrays. Let's look at an optimized solution. The optimized approach involves a two-pass strategy. In the first pass, we calculate the product of all elements to the left of the current index. In the second pass, we calculate the product of all elements to the right of the current index, updating the result array in place. This gives us a time complexity of big O of n, making it much more efficient. The space complexity is big O of n, excluding the input and output arrays. Let's now look at the code. In the first step, we initialize the result array res with ones. Then we iterate through the array from left to right and update the res array to hold the product of all elements to the left of each index. We use a variable called left product to track the running product as we move through the array. In the second step, we iterate through the array from right to left. Using a variable called right product, we update each element of the result array by multiplying it with the product of elements to the right of the current index. Finally, we return the result array, which now contains the product of all elements except the one at each index. Now let's analyze the time and space complexity. The time complexity of this solution is big O of n because we only iterate to the array twice, once for the left products and once for the right products. The space complexity is big O of n as we need an additional array to store the results. This makes the solution efficient and scalable. Let's go over a final example to see how the algorithm works. Given the input array 10, 3, 5, 6, 2, in the first pass we calculate the left products, that is 1, 10, 30, 180 and 1080. In the second pass we calculate the right products and update the result array as 360, 120, 2, 4, 1. The final result is 180, 600, 360, 300 and 900. Now let's look at a few edge cases. For an array with just two elements such as 12, 0, the result will be 0, 12, since multiplying the remaining elements gives the desired result. Another edge case would involve negative numbers like -1, -2, -3, -4, where the output would be 24, 12, 8, and 6. This handles both zeros and negative numbers efficiently. In conclusion, the product array puzzle can be solved efficiently using a two-pass approach with a time complexity of big O of n. This solution works well even for large arrays, providing both time and space efficient solution. By handling edge cases like zeros and negative numbers, the algorithm is robust and reliable.